Hello, everyone. I hope you're doing well. My name is Sayam and welcome back to the channel, right? Today, we're gonna solve the third problem of the bi-weekly contest. It is not very easy problem, but not very hard also. It's like exactly a medium problem. We'll quickly see and understand the problem statement. And with that note, let's get started then. You're given two integer arrays, technique 1 and technique 2, each of length n, where n represent the number of tasks to complete. Very, very important. There are n tasks we need to complete. Okay. Also, do let me know the feedback of I am using OneNote now. Is the previous thing better or this thing better? Do let me know in the comments. Okay. So, okay. If the IA task is completed using the technique 1, you earn technique I points. Okay, बढ़िया. And if it is complete using technique 2, you earn technique 2 I of points. You are given an integer k representing the minimum number of tasks that must be completed using the technique. That is the most important part of problem, that you have to complete at least k tasks, not exactly, not at most, exactly k tasks, at least k tasks from technique 1. But now, very, very interesting that while you are in a contest, right? Don't use this technique 1, technique 2. You can directly use T1, like in the function, right? You can, what you can do, you can go there and write technique 2 and technique 1. It will help you to do things better. Okay. Like it will help you to write your code fast. T1 and T2. So I'll use T1 and T2. You must complete at least k tasks using technique 1 I already shared with you. Remaining task may be completing using either technique. Return an integer denoting the maximum total points you can have. Right. Okay. After reading this, what intuition you get? Sayam, we firstly go to the constraints. Constraints told us that okay, it is 10 power 5. Perfect. Perfect. K is also up to 10 power 5 range. Means less than n. So, now let's try to think about. Many of the people may have thought about DP also. Let me to be very frank, because I also thought about that. कि मैंने क्या सोचा that okay, we have two choices for each task. Either we can pick what, uh, either from T1, either from T1 or from T2, and but one more state we have to maintain, that how many uh, task we have completed using the T1 task. So we have to maintain another state A, and this will create a problem. That first you can maintain the I task, like for which task you are currently at, and you have to maintain how many tasks you have completed using T1. So the total time complexity will be I into K, means N into K, which won't suffice because it will lead to N square solution. And this we won't accept this. How can we make this better? This is our challenge, right? This is our challenge. Can we make it better? So instead of going through DP idea, let's try to think about a greedy idea. Let's try to think about that. Okay, see this example itself. We have what, 5, 2, 10, and I will make in front of you, that will make things more clear. 3, 8. Okay, we have these things. Now the interesting idea is, let me know one thing, that if I remove the concern of the K part, how would you decide that what to pick for maximization of point? Because for each task, you have to decide exactly one, either this or this. So Sayam, it is very simple. What is the need of DP? Pick the highest one. Pick the highest one. Absolutely. You are right. You are absolutely right. We can do that. But this is the most optimal answer if there was no condition. But here is a condition, that you have to pick at least k elements from T1. Hmm, that makes sense. इसका मतलब क्या है? We have to do a trade-off. And now people can think, अरे it is very simple. Another greedy idea we can think of, that what we can do, we can just sort it out what T1, and we will take max top k from T1, and remaining we can decide the max from T1, T2 remaining. Can we do this? No. Why? Why can't we do this? Let's try to understand that. Let's suppose we pick, let's say their largest are 4, 5, 6, and 1, 2, 3, something like that, and our k equals to 3, and this is T1. Okay, what you did, you pick the largest things. Okay, you sorted down and you pick the task, but remember that for the particular task you have picked for T1, now you cannot pick for T2. Let's say for the same task, it was 10 power 9 here, for 10 power 9 here for T2, and you miss that because for this small 4 or maybe 6, right, you miss this part. Instead of that, what you can do? Instead of that, you can pick off another task. You can pick 3 for T1 for that case, and you can pick 10 power 9 from here. You have to maximize from both the sides, right? It does not matter from T1, you're maximum T2. Combinedly, you have to maximize. That means we cannot trade off on T2 on the basis of that. So we have to consider T2 also while considering this top K. We cannot do independently from T1. Right, Sayam, right. So what we can do? What is the operation that will tell us that contribution from T1 also and T2 also? Hmm. Hmm. We have to pick from T1 definitely. But that is the point I want to make a greedy choice. That let's try to think of that the difference, because that is the trade-off, right? That will exactly tell me that what is the trade-off I am currently doing. So what I will define, I will define another array, let's say T, which will be what? T1 of I minus T2 of I. Firstly, I did T1 of I because I have to take from T1. Fine. This is the array, I will get it. And then what I will do, I will sort it, and I will reverse sort it. Reverse sort it. And I will pick top K from here. That is the idea. That is the idea. Why it will work? See, it could be negative also. It could happen that T2 will be larger in these cases, but the damage is minimum because we were sorting it on the reverse. At the last, at the top, it will the largest will come. The largest difference means what? That we're trying to maximize T1 minus T2. That is our idea. We'll those first, then those first K, and then we will remaining we will pick. That is our call logic. How does that it will help us? Because see, we have to pick at least K, pick at least K, and now we have to do a trade off also. In this case, it will also handle that case. Okay, if T2 would be very large, right? It will be come at very end stage. The difference will be very negative, and it would come at very later stage. So we won't contribute in our first K task. That is the idea. So what we are doing, we have to pick at least K. So what we are doing, we're picking a difference array, which will tell us ki, acha, this is more fruitful because T1 is greater here. The difference is good. The larger the difference, the better it is to take from T1, right? That is the idea. And that's why we'll sort it and take top K from it. And the remaining elements, it's very simple. Remaining, it's very simple. What we'll do, we'll go and take max of T1 of I and T2 of I. Now the interesting idea how to implement this, how to implement this. Let us try to see quickly. So just give me a second. So how we can implement this is like this. Yeah. So what we are essentially doing, okay, let me just make it larger also for you. Uh, yeah. Mm, yeah. So what I'm trying to say is now it's very interesting that how you can implement this, right? That is also the idea you can think of. Now, the interesting idea is you have to maintain the differences, but you also need to know the indexes also, right? Which task you have already done in the top K, because K are not the first K task. It already mentioned in the question. You can pick any K task. So what we did, we took the difference, we sort on the reverse. We did the first K task, and we took T1 contribution from there, not T2. T1 contribution. Now what we'll do? What are the remaining things? So we will go from equals to K index till N index, right? We'll go from these indexes, and whatever the index at that array, whatever new array we form, we'll pick that index, and then we'll take the max of that T1 of that new index or T2 of that new index. That is the idea, right? That is the idea. So let's try to see. So firstly, what we did, I made a pair. Because I need to store the difference, I need to store the index also, because the index cannot be lost, right? I just created the difference, I just created the index, I just reverse sorted that, and then firstly I pick the first key elements. Let's try to see also in here, does it applies? See, what I've been trying to do is, here in this case 10 5 10, I will make a difference area minus 5, this is minus 1, and it is 2. So I will reverse sort it, which is 2 minus 1 and 5, and I have to do the first k task. So I will pick, it's minus 5, sorry, I will do these two tasks first, definitely. So what I will do, I will do this task, I will do this, I will ignore, irrespective that 5 is larger than 2, I am doing this task because the difference is what is important here, right? So this I will do, this I will do. So I will pick 10, I will pick 2, and all I will pick 10 from here because the remaining task is there, right? That's why 10 plus 2 plus 10, that is why 20. You can try any other way, it won't work, it will be the maximum, what I'm trying to say, right? And this, what we are doing, then we are iterating this. We did the first k task and the remaining k task k to n, but now see, we, the index is not sorted initially, we are doing that v o I dot second. We know the index, we'll get this index from the second value because we already stored the index here. The index will be useful. Answer plus equals to p1, if p1 dot I positive, that means what, maximum, like because we are storing the difference, if the difference is positive means t1 wala contribution is greater, so we'll pick this one. Otherwise we'll pick t2 wala contribution above. It could be difference, could be negative also. I hope you are getting it. We just pick because it is less. And this is the idea, and this finally we return the answer. So I hope you understood the entire intuition, the thought process. If you learn something new out of it, do subscribe to the channel and like the video. We'll see you in the next question then. Till then, keep learning. Goodbye.